Let us talk about cryptography today. Now, cryptography, we will look at what is cryptography, the purpose of architecture, the types, process, and some of the algorithms. This all we will see in this particular presentation. Now, what is cryptography? Before we go to it, let us see why cryptography. Now, the internet or any other thing, any other system which is connected to internet, it is actually internationally connected to computer networks. They have some addresses that are administered by who? Internet Address and Naming Authority, IANA. Now, there are many aspects of security in many applications. You have commerce applications, you have banking applications, you have your own social media applications. There you need to protect your passwords, and you have certain private communications. Now, the essential part or essential aspect of your secure communication is what we are talking about, cryptography. What is cryptography? Crypto, actually it has come from crypto. Cryptography from crypto. Cryptography is derived from the Greek word which is called the cryptos. It is called cryptos. That is the hidden secrets. It means that this word meant hidden secrets. So actually this science is a practice and study of actually hiding the information. This is art and science of converting a plain intelligible data which you know into an unintelligible data which people don't know, and again retransforming that message into its original form. Means good data to a cryptic data, then to again a good data. That data which is cryptographically done is not been known by anybody. Okay, so what it does, it provides confidentiality, integrity and accuracy. What is the purpose of cryptography? The main purpose of cryptography is authentication. Means how can you prove your identity? Anybody can enter, so there has to be a way of authentication. Okay, now privacy and confidentiality, as I mentioned earlier, that your message is your personal, it is your confidential messages or stuff. Nobody is allowed to see it unless until you are a culprit in some sort. And then integrity, that receiver which you are sending messages, it has not been altered in any way. This may happen that what you are sending may be changed in some manner. So integrity is also a part of cryptography. Then non-repudiation, that means a mechanism to prove that the sender really sent this message. Okay, means somebody else has not sent. This is the architecture of cryptography. Okay, this is some private key. Now this is somebody's message. We have some random session key, and this is some other person's key. Okay, this is the public key cryptography. This is the hash function. This is the secret key crypto, and this is again the public key crypto. So what it does is there is a digital signature, and now public key, the private key of Alice goes to public key of crypto, this cryptographic public key, and now some digital signature is there. And now this message, this is a digital envelope, encrypted message and then encrypted session key. There is a message which is encrypted by this secret key. This secret key is neither known by Alice nor known by Bob. Okay, and now once this envelope has been made, it is sent to the Bob, means sent to the other person. So this is how it's done. There are various things which are involved. We have public key cryptography, then the hash function, and the secret key cryptography, and the public key. Public for this, and in between we have two things, that is a secret key crypto and hash function. Now what is this secret key cryptography? This is a single key used to encrypt and decrypt Imagine a lock. You have a key, a single key. So key must be known by both parties. Key must be known by both the parties. So assuming we live in a hostile environment, okay, otherwise why the need for cryptography? There is an environment where messages can be breached, so it will be hard to share a secret key, right? And what is public key cryptography? One of the keys allocated to each person is called the public key, and is published in an open directory somewhere where anyone else can easily look it up. For example, the email address. So each entity has two keys. We have private key and we have public key. This private key is a secret, public key is known, so we rely upon this basically. So how to use this key? Private keys are used for decrypting and public key are used for encrypting, right? You need a private key to decrypt. That is why everybody cannot decrypt. This is a plain text. This is a plain text. Now by public key, what you do is you encrypt it. You encrypt it. Now when you encrypt your data with some or the other thing, it becomes a ciphertext. Now this text is now not known by everybody. It has some key. It has been encrypted through public key. Now this ciphertext can only be made to the plain text or the main text via a private key. Remember this. So the process of cryptography is we have this somebody's A is public key, this is a secret key. So this data will be encrypted using public key and this will be decrypted using our secret key. Again, any data can be encrypted via public key. Anybody can do the PCD. Any data can be encrypted, right? But it can only be decrypted by this secret key. So the types of cryptographic algorithms are, we have some plain text, it goes to ciphertext and it becomes again plain text. We just saw that. So secret key, which is a symmetric cryptography, this SKC, secret key cryptography, SKC, uses single key for both encryption and decryption. Both the keys are same. See, this is the same, see the color, yellow. So in SKC, both the keys are same for encryption and decryption, while in public key cryptography or asymmetric cryptography, this PKC uses two keys, one for encryption, other for decryption, while the hash function or one-way cryptography, it uses hash function. Hash function has no key since the plain text is not recoverable from the ciphertext. Okay, once this hash function, it does not require any this key, because it itself, the plain text cannot be recovered from the ciphertext. You have a hash function here. So this public and private key cryptography, this asymmetric key cryptography, this overcomes the key management problem by using different encryption and decryption key pairs. So having knowledge of one key, say the encryption key, is not sufficient enough to determine the other key, okay, the decryption key. A mathematical relationship between this public and private key pair, it permits a general rule. So any message which is encrypted with one key of the pair can be successfully decrypted only with the key's counterpart, right? And if we talk about our hash function, so it is a type of one-way function that is a fundamental for much of the cryptography. One-way function is, it is a function that is easy to calculate but hard to invert. You can compute it, but how to get it back? So it is difficult to calculate the input to the function given its output. It is not possible, very difficult. So the precise meaning of easy and hard can be specified mathematically, which I just said. With rare exception, almost entire field of the public key cryptography rests on the existence of one-way functions. And the attacks on cryptography: ciphertext only attack and known plain text attack. So ciphertext only attack means the only data available is a target ciphertext. ciphertext is which has some cryptic thing done on it, while known plain text attack is a target ciphertext, means pairs of other ciphertext and plain text, say previously token or guessing. So this kind of attack may happen. Also, if you have chosen plain text attack, means a target ciphertext, this can feed encryption algorithm with plain text and obtain the matching ciphertext, right? You can feed the algorithm with certain plain text and you can obtain the matching ciphertext. You can have a target ciphertext also. And while chosen ciphertext attack is a target ciphertext, what is this? Can feed decryption algorithm. Here we are talking about encryption algorithm. Here we are talking about decryption algorithm with ciphertext and obtain the main matching plain text matching ciphertext. So here we are actually finding out the ciphertext. Here we are actually finding the plain text. So the conclusion is we use different types of algorithm to establish security services in different service mechanisms, and we use either this private key cryptography or public key cryptography, which is your requirement. And if you want to send message quickly, we use private key algorithm, and if you want to send message secretly, we use public key environment. Like in the public key we have email address can be a public key, while in this is duly a value which is not known by everyone. So thank you so much. Take care of yourself.